Another skill that we need to pick up along the way is this idea of how do we, if we get a partial trinomial, how do we make it a complete perfect square trinomial? So for example, if I have 8x, or I have x squared plus 8x, what goes right here? What number would go right there since this turns into a perfect square trinomial? And the reason why I'm asking that is because I know how to factor a perfect square trinomial. Uh, it's fairly straightforward. I can just plug it in. So I was wondering, what is a perfect number that would go right there? And maybe you're starting to get the idea and think about is, well, is it a, I don't know. Well, maybe a 16. 16 looks like it's got to be the right number. Because one, I know the last number has to be a perfect square. And the first couple of choices are 1, 4, 9. Those don't feel right. 16 is a perfect square. And let's just see if that's the case. Where that factors, the factors of the last that add up to the middle, that does factor to an x plus 4. Or I could write that as an x plus 4 squared, which was my goal to begin with. I wanted to find a perfect number, and I don't know what it was, that if I were to factor it, it factors through into what we call a perfect square, factors down as a perfect square. So I got to figure out a strategy. How do I come up with this 16? How do I just pull that out? Or what am I going to do if it's different numbers? Well, what we have is this idea of called completing the square. And if I have some partial trinomial, x squared plus bx, and I need to add to it something, well, to make it a perfect square trinomial, basically I'm taking this number, divided by 2, and then squaring it. I'm basically reversing what I did earlier, what I was factoring. I'm doing the process backwards. And so the process backward tells me is, well, first, take this number, divide by 2, and square it. So let's see if that happens right here. Take this 8, divided by 2. I get a 4, and then square it, and I get a 16. And 16 is the only number that turns this partial perfect square, or this partial trinomial, into a perfect square trinomial. So 16 is the magic number. And how I kind of remember that is I'm working the process backwards. So I take this middle term to start off with, find half of it, and then I square it to give me my perfect number. So let's look at another example right here. X squared minus 7x. Well, Willie, if this process is what you're telling me is true, and I'm starting to work out enough problems where I'm getting a sense of, yes, this is something I've learned before. I don't recognize it yet because I was always doing the problems one direction, but now I'm kind of doing them backwards. So let's take this middle term, which is a negative 7, divided by 2. So I just have negative 7 halves. And then I'm going to square it. So squaring it, negative 7 halves squared, negative 7 times negative 7 is a 49th over a 4. So what this becomes then is that this is the only number, 49 fourths, that turns this beginning trinomial into a perfect square trinomial. So this factors down then to, since it was a minus there, it factors down to an x minus, and an x minus factors down to x minus 7 halves and x minus 7 halves, or written in the way that we want it to be written, is x minus 7 halves squared. And then if you really need to prove it to yourself, let's just multiply it back out. X minus 7 halves times x minus 7 halves. Let's FOIL that out, multiply it. I'm just using a stacking method to begin with. 7 halves, negative 7 halves times negative 7 halves. That's a plus of 49 fourths. These two terms, that produces a negative x, well, negative 7 halves x. Another negative 7 halves x. And then first times served first is x squared. Add those up. I have an x squared at the beginning. I have a plus of 49/4 at the end. And then I just need to add, how do I add a -7/2 plus a -7/2? That produces a -7x. So that indeed works itself out. Last example I have, x squared plus 35x. It's the starting of a trinomial. I want it to be transformed into a perfect square trinomial. So what's the magic number over here? And you see this middle fraction that I got to deal with, so we're going to have to deal with fractions. Take a deep breath. We can do it. So I take this middle term, divide it by 2, which is either dividing it by a 2, and if we remember how to do that, or if we haven't been introduced to that yet, or worked with that yet, it's basically taking a 3/5 and dividing it, multiplying it by a 1/2. And that produces a 3/10. Once I have my 3/10, which is this middle number divided by 2, I square it, and I'm left with a 9/100. So that's the magic number that now transforms this partial trinomial into a perfect square trinomial. And once it's in a perfect square trinomial, I can go ahead and factor it down to x plus the square root of that, which is 3/10 squared. And now I have a perfect square trinomial, and now I was able to factor it down into its factored squares.